Today we're going to talk about indices. Indices involve powers of numbers. So an index, the singular, is the same as a power or an exponent. Example, r to the power of 2, which is r squared. Here the base is r, and the power or the exponent or the index, as it's also called, is 2. It's the number to which the base is raised. We can multiply and divide indices. So let's look at a few examples. We want to simplify the following. In the first example, b to the 5 over b to the 3. When the bases are the same and we're dividing, we subtract the powers. So it's b to the 5 minus 3, which is b to the 2, or b squared. All the answers are highlighted in green. Second example, 4ab cubed times 2a squared b to the 5. Well, if we do the numbers and do each letter separately, that's by far the simplest way of tackling these. So for the numbers, we have 4 times 2. For a, we have a times a squared. For b, we have b cubed times b to the 5th. Now, a on its own doesn't have a power, so when there's no power, we take it as a 1. When we're multiplying them together, we need to count it as a 1. So for the numbers, we have 4 times 2, which is 8. A gives us a to the 1 plus 2, which is a cubed, and b gives us b to the 3 plus 5, which is b to the 8. So the final answer is 8a cubed b to the 8. The next one, we apply the same kind of logic. This time we're dividing. So 6 over 2 is 3. A over, there's nothing on the denominator involving a, so it's just a. And then b cubed over b squared is equal to b cubed minus 2 as the power, so it's b to the 3 minus 2, and that's just b, so the answer is 3ab. For the next one, it's slightly different because there are some negative exponents. Don't be too scared about these. We just apply the same rules the way we did before. So 4 times 3 is 12, that's for the numbers. For the a terms, we have a to the 4th times a to the minus 2. So we treat it the same way we did before. We're just multiplying indices, and then we add the powers. So it's 4 plus minus 2, which is 4 minus 2, which is 2. And then for the b's, it's b to the 5 times b to the minus 3, which is b to the 5 plus minus 3, which is b to the 5 minus 3, which is b squared. So the answer is 12a squared b squared. Now in number 5, we have the square root of a, all raised to the power of 4. Now the square root of a, we need to convert that into index form, and that's just a to the power of a half, or a to the power of 0.5. You will learn that in maybe some of your other mathematical courses. But yeah, when you see a root, think of to the power of a half. And when you think of an nth root, if it was the cube root, it would be the power would be a third. The nth root, the power would be 1 over n. We'll look at that later in the video. But for now, the square root is a to the half, and then we're raising that all to the power of 4. So we just multiply the indices. So it's a to the half times 4, which is a squared. An alternative way of tackling this would be to write it out in full. So you'd have root a multiplied by itself 4 times. Root a times root a times root a times root a. And then if we treat them as 2 sets of root a times root a, then we take the first one, root a times root a, well that's just a. You will learn that in your surds courses. If you have the root of a number times itself, times the root of that number, then it's just the number. For example, root 3 times root 3 is just 3, because it's root 3 squared. So it's the inverse operation. You're taking the square root of something and then you're squaring it. You just get back to where you started. So the yellow one, root a times root a in yellow, is equal to a in yellow, and root a times root a in blue is equal to a in blue. So the final answer is a times a, which is a squared. As I say, it's just an alternative approach. But once you know that root a is the same as a to the 0.5, you can quickly multiply them using the first method. And then finally, 4b cubed plus 2a squared. Well, we can't really do anything with that. The numbers are different, but that's not really important. What's more important is that the letters are different. So we've got B's on one side and A's on the other side. And yeah, so you can't simplify that any further. Now we can add and subtract indices, but only in certain situations. Example 1, 4ab cubed plus 4ab cubed. Well, if we look for a common factor, then a common factor on both terms is ab cubed. So we take the ab cubed out, so the first term becomes 4, and then the second term plus 4, all times ab cubed, because we're factoring out the ab cubed. And then that's equal to 8. The 8 comes from 4 plus 4 times ab cubed. So the answer is 8ab cubed. So the common factor there was actually 4ab cubed. But we took out ab cubed in that method. So, but now we're actually going to take out 4ab cubed. So if we take out 4ab cubed, it becomes 4ab cubed, and then in bracket 1 plus 1. It's pretty obvious where that comes from. 4ab cubed is equal to 4ab cubed times 1. And then that's equal to 4ab cubed times 2 in a bracket. 1 plus 1 is 2. And then you're just doubling 4ab cubed. So it's 8ab cubed. Again, it's entirely up to you which way you want to do it. They both get the same result. Example 2, where we subtract. So we have 8ab cubed minus 5ab cubed. So here the common factor is ab cubed. So we take ab cubed out, and then for the first expression we're going to have 8. For the second expression we're going to have minus 5. All in a bracket, times ab cubed. So 8 minus 5 is 3. So the answer is 3ab cubed. So we factorize the expression, guys. We look for a common factor in the terms. Some other important examples. Prove that a to the power of 0 equals 1. Now this is a very fundamental principle in indices. When you raise a number to the power of 0, you get 1. The only exception is if the number that you're raising the power to is 0. So a is not allowed to be 0 here. We will look at 0 to the power of 0 in another video. It's quite a complex concept. It's not as obvious as you think, but we'll discuss that in another video. Anyway, so a is not allowed to be 0 for this video. So a to the 0 equals 1. Let's prove that. So a to the 0, we can rewrite that as a to the x minus x, where x is a number. So x minus x is 0, as you know. That's pretty obvious. And then by the rules that we looked at earlier, this involves subtraction of indices. So when you see a subtraction in the exponent, then you have to think of division. So a to the x minus x, because we're subtracting the powers, that's the same as having one and dividing it by another. So you convert that to a to the x over a to the x. So a to the x over a to the x. The bases are the same, we're dividing, so we subtract the powers. So it's a to the x minus x. We're just going in the reverse direction. So you need to be able to handle these guys. You need to know how to go in both directions. And then that's obviously equal to 1, because something over something is just 1. Now, what's very important is that a to the x is not allowed to be 0. And a is also not allowed to be 0. Okay, prove that a to the minus x equals 1 over a to the x. So whenever you see a negative power, all you really need to do is to convert it into a positive power is you take 1 over the positive power. So a to the minus 3 equals 1 over a cubed. A to the minus 7 equals 1 over a to the 7. So we're going to prove that. So a to the minus x, we can rewrite that as a to the 0 minus x. And we can rewrite that as a to the 0 divided by a to the x. And as we just proved, a to the 0 is 1. So that's equal to 1 over a to the x. Again, a is not allowed to be 0, because that would involve division by 0, and that's not allowed. And then simplify a squared, all in a bracket, to the power of 3. So a squared all cubed. Well, if you see an expression like this, you just simply multiply the powers. So a to the power of 2 in a bracket to the power of 3 is equal to a to the power of 2 times 3, which equals a to the power of 6. Some formula which you should memorize, they may give you them in an exam, but just in case they don't give you in an exam, try to memorize them as well. That way you can solve these problems a lot faster. So a to the x times a to the y. So bases are the same, multiplying, so we add the powers, so that's a to the x plus y. A to the x divided by a to the y, bases are the same. We subtract the powers, so that's equal to a to the x minus y. A to the x all to the power of y, we just multiply the powers together, and that equals a to the xy. A to the 0 equals 1. We already proved that. We're assuming a is not 0. A to the minus x equals 1 over a to the x. We just proved that as well. And we're assuming a to the x is not 0. And now let's look at roots. The root of a, or the square root of a, is equal to a to the half. The nth root of a, so the little n on the left denotes the nth root, is equal to a to the 1 over n. So the cubed root of a is equal to a to the cubed, a to the 1 over 3, sorry. The fourth root of a equals a to the 1 over 4, or a to the quarter. And finally, some other general formula. AB all in a bracket to the power of x equals a to the x times b to the x, i.e. the power of the product equals the product of the powers. A over b all in a bracket to the x equals a to the x over b to the x. The power of the quotient equals the quotient of the powers. The nth root of a to the m, so here a could be raised to any power, m, is equal to a to the power of m over n. So the nth root of a to the power of m. In the previous slide, it was a to the power of 1, or a. A few examples. AB all in a bracket squared equals a squared b squared. Example, 2 times 5 all squared equals 2 squared times 5 squared. You can quickly verify that on your calculator. 2 times 5 is 10 squared equals 100. 2 squared times 5 squared equals 4 times 25, which equals 100. A over b cubed equals a cubed over b cubed. Example, 4 over 2 cubed equals 4 cubed over 2 cubed. Quickly verify that. 4 over 2 is 2, cubed is 8, and that's equal to 4 cubed, 64, divided by 2 cubed, 8, so 64 over 8 is 8. Then the cube root of a to the power of 6 is the same as a to the power of 6 over 3, which is a squared. Example, the cube root of 2 to the 6. 2 to the 6 is 64. When you take the cube root of 64, you get 4. Now we're saying that's equal to 2 to the 6 over 3. Well, 2 to the 6 over 3 is just 2 to the 2, which is also 4. So that verifies those results. So that concludes the video on indices. I hope you have fun. And thanks for watching, and please subscribe. See you on the next video.